Okay, so this is the pipeline detection. This is very simple application of any flow meter, pipeline leak detection. And this is used most for flow meters used for this application. At the starting point, I have a flow meter, and another point in the section, I have a flow meter, and I am measuring the flow and the total, both values, and we will understand if there's any leakage or there's any unauthorized people are drawing the fluid or the water. You see the theft of the oil and gas also, and in the water also. So another example in this application is in a blast furnace. When steel making, it's a blast furnace, and there were tuers to cool down the shell of the furnace. So there we use the match pair flow meters, and if there's a readings or not matching of two flow meters in an inlet of the flow tuers and the outlet, then immediately we will switch on the another tuers to prevent this kind of any overheating in this furnace. So this is very interesting and very important application for the flow measurement. And then batch processing. The batch processing, this is again a very important, and I have a one batch meter with me, right? These batch meters, that batch meters are used when you are using it in a filling applications like Coca-Cola, Thumbs Up, or different kind of SEP industries. SEP industry means different kind of the oil industries. So this kind of batch flow meters are used. In a batch size is fixed, and when on the table the bottle is coming, it comes there at place, and whatever flow we have decided, it will come out from the flow meter and stop, and the second bottle will come. This kind of the flow meter used for the batch flow meters. And the people who don't understand what the batch. So in the morning you go to your kitchen and see the oil, the milk, and tomato sauce and all. Everywhere you see the batch number. So in that particular batch, what is the quantity they need? They're done by this flow meters most of the time. Then revenue generation. What is the revenue? Because you know there's a department in the government department, revenue department. So whenever these flow meters are used, when one person who is taking the material, fluid or material, and one is giving, and if there's a give and take is the terms of the money, then these flow meters are used in a revenue generation. Examples. The examples are like you see a bigger examples. The Bombay High. Bombay High is giving crude oil to whom? BPCL and HPCL refineries. So there, what flow meters are used are called the revenue generation application flow meters, right? In your petrol pumps, right? In the oxygen plants. Then oxygen plant people are giving this oxygen to hospital or the industries. So there's a money involved. So they measure that oxygen, nitrogen, and other gases flows, or oil and gas, the crude oil, petroleum products, and even water. Nowadays, this is very important. Revenue generation example is your small flow meter used for your domestic measurements. It's called the domestic flow meters, which are fixed at the inlet of your house, and depending on the water consumption in that flow meters, you have to pay to the municipal corporations. So these are the applications, or different applications of the flow meters. And there may be more also depending on these, but this is the major pointers. Now, if I ask a question, what is flow? What is flow? So how many of you can give me answer of flow? Right? Now you can read it. And I will tell you in instrumentation, most of the time, the definition of these parameters, you need not to cram, okay? It is very simple. If you know its unit, like flow, m cube per hour, or ton per hour, TPH. So with this unit also, you can give me the definition of flow, which you are not able to tell me right now. But after this session, you always remember these definitions. Now you see, how you can see here, you see like this, a certain quantity means m cube, a certain quantity means ton, when you talk about the mass or the volume, then which passes through a section of a pipeline or a channel in a certain time. Channel, what do you think of channel? Pipeline, we all know. Channel means, hello, channel means nali, nala, canals. They are the open channel. In some countries, they don't have pipeline supplies. They have channels come to your nearby to your houses. From channel, they are taking the waters. Okay, these are open channel, and we will also study when we go to these slides and all, open channel flow meter. That time you see a simple level measurement device are used as a open channel flow meter. So what is definition? Certain quantity passes through a section of a pipeline or channel in a certain time. Means quantity and time. Right? M cube per hour. Ton per hour. Cusack, hello, Cusack. This is a much bigger unit of a water. When the water is that dams and all, they give the water the city, is at that time the dimension, the Cusack. Okay. Now quantity is generic term of mass or the volume, means M cube or ton. Now very important point is coming now. This point is the gases volumes is dependent on pressure and temperature. This is a very important point which you see when we do the measurement of gases and the steam. So then STP and NTP will come, and when we will study the vortex flow meter, that time we will see this in a more detail. So next is the terminology and the flow basics. This is a very important point because I will tell you one very important point. Most of the flow meters are not flow meters. Not flow meters? Yes, most of the flow meters are not flow meters. These are velocity meters, because we measure the velocity of the fluid and multiply by the area. We get to know what is the flow. How? Q is equal to area into velocity. Again, I am telling about the dimensions. Q is equal to area into velocity. What is the dimension of area? Meter square. What is the dimension of velocity? Meter per second. Then what is the unit of the flow? M cube per hour. So the same thing is given here. Q is equal to VA, velocity into area. Okay. ये तुम कर लेना बाद में. Velocity into area. So Q is here, liquid flow through the pipe. What is the velocity? Is the average. See, now very important point. This velocity is the average velocity. When we touch upon the electromagnetic flow meter and ultrasonic flow meter, and clamp on ultrasonic flow meter or the inline ultrasonic flow meter, that time this average velocity we will discuss in more detail. What is the area? Area is the cross section area of that pipe. Now another very important terms in a flow metering is continuity equation. The term is continuity equation. What continuity equation says? This is very important when we do the flow metering, because in my industry, in my institution, the pipeline is not same size. Here line is 12 inch, then 10 inch, then 8 inch, then 4 inch, then 2 inch. Like that, line size will change. So here it's a very important thing is continuity equation. Q is equal to AV. Now this AV equal to constant. Hello. Q is equal to AV. And this AV equal to constant, means what? A1 V1 equal to A2 V2. See here, like this. What it mean, my dear friends? What it mean? Q is equal to AV, AV is equal to constant, and A1 V1 is equal to A2 V2. Here you see. If you see here, A1 V1 equal to A2 V2, or I told you A dot V is equal to constant, means if area increased, velocity will decrease. When velocity increase, then area will, hello, when velocity increase, area will A1 V1 is equal to constant. If velocity will increase, then area will decrease. In a 2-inch pipe, velocity will be high for the same Q, and in a 4-inch pipe, velocity will be less. This concept is very important when you do the troubleshooting, when you do the NRW calculations, when you are do the water balancing in a plant, when you are doing the water audits, when you are doing the troubleshootings of the flow meters. That time this concepts play a major role. So please don't forget this. Do some self-study also on this. Now you see the verbose. You can also read yourself. Okay. Now very important points are coming here, and that point is Reynolds number. This Reynolds number is very important when you are talking about flow measurement. But most of the time, this important term is just like a USA. Huh? USA? We are studying flow metering. How come a USA came here? USA means everyone knows. The word Reynolds number, everybody knows like USA, United States of America. But what it is meaning to you, you don't know. So now we try to understand what is the Reynolds number and what is its meaning, practical meaning related to flow. Because in theory we have studied many things, but when I ask what it means, you are not able to give me answer. So that answer we are going to see now. My first question to you: what is the fully developed profile of a flow meter? I will again asking the same thing. What is the fully developed profile of a flow in the pipe? What is the fully developed profile of a flow in the pipe? Number one. Number two question. Whenever we have a flow meters and we have to install the flow meter in my premises, whatever is the institutional building or my plant or my house or my building, then we have to consider state runs requirements. Then what is the relation between this state run requirements, why I need a state run requirements for a flow measurement, and how it is connected with this magic number. Now third question, what is the dimension of this magic number? So we will see one by one these answers. So first, last question was dimension. So it's a dimensionless quantity. This Reynolds number don't have any dimension. Why? Because this is the ratio. If anything is ratio, then its dimension will cut. So it is having no dimension. Please, if you don't know, you know it. Then this is the ratio of what? This is the ratio of liquid's inertial forces to drag forces. What is the meaning of that? What is the meaning of inertial forces and the drag forces? So we will see it in the next slide. What is the meaning of last two questions? So what is the meaning of fully developed profile? How it looks? To understand this, what we have to do it, we have to draw some sketches to understand. Now, my dear friends, how your pipe look like? Your pipe is look like this. Okay. Now we all know water flows in layers. Okay. So these are the, I will just change the color for you for better understanding. These are the layers. Okay. These are the layers. These are the layers of the water. Okay. Now I am telling you what is the meaning of fully developed profile. So my dear friends, the answer is the fully developed profile of any flow is parabola. So I will get some answer from you, the parabola, but I will ask how? How? Then the same magic number will play, because that magic number is ratio of, hello, ratio of what? It is a ratio of inertial force to drag force. Now you see here, the layer at the mid, the layer at the mid, and the layer at the surface of pipe. Where velocity will be high? The velocity will be high, or we can say maximum at the midpoint. And where velocity is ideally zero or the minimum? Hello? Hello? Newton's law. Where ideally velocity will be zero. The velocity will be zero ideally at this surface. I can say here ideal velocity will be zero. So what will happen? Velocity V max is here. Then here V max minus delta V. Then here V max minus delta D, delta V, delta V, delta V. Like here also as like this. So if I will make this clearly for you, it will be like this. This is your pipe. Okay. Velocity here maximum. Then like this. Then. And what will it make? It will make the parabola like this. And why straight runs are required? Because if the flow is in a fully developed profile, and when it will go through my flow meter, that time it will measure better. So my accuracy will be better at that point. So that's why any flow meter, while installing, we have to follow the manufacturer's guidelines, how much straight run I need before flow meter and after flow meter. But technically we say upstream and downstream. Upstream means from where water or fluid is coming, or gas is coming, or steam is coming. And downstream is where it's going out from the flow meter. It may be steam, it may be gas, it is water, it may be acid, whatever it may be, fluid. So this we try to understand, and these all things, okay, these are the verbose. So just you have to read from your books. I need not to tell you these all things. But what I need to show you, I want to show you internally how it looks when this fluid goes to the pipe. And when picture is taken by the high speed cameras, then how it looks, that I want to show you, because you cannot imagine that. See. So when we study vortex flow meter, when we study office flow meter, when we study Mach flow meter, when we study mass, no problems. Okay, but other flow meters, we have to consider these all things. You can see fully developed profile. You can see fully developed profile here. Here you can see. And here you can see like this. So this is the importance of that magic number, and its importance in fully developed profile means, hello, parabola. Okay. Now, our next topic is the various flow meter types. So here, what I try to tell you, I want to tell you there are major 5 principles. Based on these 5 principles, there are a lot of flow meters. And in that lot of flow meters, we will study only those flow meters which are commonly used, and you can see when you walk through the plants. Okay, it may be process plant, it may be your institutional building, it may be your house connection flow meter also. Okay, any kind of fluid, any kind of acids, any kind of gas, and the steam of also any times, 3 times of steam. You know, when we have a session of the steam, then we will discuss about those different type of steams also. So now, my dear friends, I can say you principle number 1, principle number 2, principle number 3, principle number 4, and principle number 5. They are the 5 principles. DP, differential pressure. Okay, PD, is this a DP? This is a PD. Okay, this is not DP Singh, PD Singh. These 2 fellows were working with me, but they are different. This is the differential pressure, and this is the positive displacement. So how it go and how it works, I will tell you in the next slide. So based on this head producing flow meters, how many kinds of flow meters? Now you see here. Oh, for head so much. Oh my God. So here in this so much, some are dinosaurs, and some are US. Dinosaur means you can not see anywhere, or sometimes you see na labs, laboratories. If you go FCRI, CWPRS, or some other colleges and research centers are having, and few are commonly used. Then you will see PD. This is the PD, diaphragm seal and the mechanical seal. Then velocity. And here also, if you talk about the DP meters also, all positive displacement also, and here when you go inside the definitions and the formulas and the principles, you will find this DP also they are missing the velocity. Okay. Then velocity is turbine, electromagnetic vortex, then ultrasonic and the sonar. Direct mass, very interesting, huh? Mass meter and direct mass meter. So coriolysis and thermal mass flow meters. And infrared, there are some infrared flow meters. Now, hello my dear friends, you can comments also in this slide, because when I did my own research on flow measurements while during my MS, I got to know these 36 flow meters based on those 5 principles. If you know anyone 37, 38, 39, 40, please do a comment or call me. I am very thankful. Many professionals and students are also calling me and telling, suggesting and informing what to do next. And my voice is not okay, my video is not okay, PPT not okay, or it's okay. So please, all are welcome, and your love and affection will grow this channel more. So these are the 36 flow meters I found. You take it snaps also. You go, you do your own research in your plant, and you come back if you found any other things, other flow meter 37, I will add that. Okay. Now, world flow meter data by technology. Some data is old, but it is also applicable. So this is the data. Open channel flow meter, you have seen that. Means canals, right? Wages, right? Nadi, nala. If I want to measure, that's the open channel. And we have a ultrasonic flow meter for the label, and there's an equation between the square root, some 3/2 root kind of equation is there, height and the cube, the mechanical structure. And in that mechanical structure, what we will do, we have ultrasonic label transmitter, and this equation civil, from getting this from the civil design, we put in the ultrasonic label, and it will show us the direct flow by the measurement of the label. So this is the value, this is the percentage. But now if you see in today's context, the vortex in a steam, the vortex in the steam, magnetic flow meters in the conductive fluids are increasing. Even ultrasonic. Earlier days, ultrasonic flow meter, the problem is they cannot work for the more than 120, 30 degrees Celsius. But now technology evolved. Even in a steam, these ultrasonic flow meters can be used. Thank you very much. We will make another video in different parts in a coming days. Thank you very much.